This is the lock and key mechanism, and it basically shows that the substrate and the enzyme, the substrate will go into the enzyme and it'll fit in. This forms an enzyme substrate complex during the reaction, and after that then the products will come out as separate ones. The lock and key model states that the active site of an enzyme precisely fits a specific substrate, and the enzyme substrate interaction suggests that enzyme and substrate possess specific complementary geometric shapes that fit exactly into one another into the active site. Active site continues to change until the substrate is completely bound to the active site of the enzyme, at which point the final shape and charge are determined. This is the induced fit model, and this is an enzyme and this is a substrate. During the induced fit model process, the substrate will go into the enzyme, which forms an enzyme substrate complex, and eventually during the reaction, new products will form, two separate products. And soon the products will come out as two separate ones instead of the substrate before. So there's two different products that come out from it. The induced fit model states a substrate binds to an active site and both change shape slightly, creating an ideal fit for catalysis. Enzymes promote chemical reactions by bringing substrates together in an optimal orientation, thus creating an ideal chemical environment for the reaction to occur. Both the substrate and the active site of the enzyme change in conformation until the substrate is completely bound to the enzyme, at which point the final shape and charge is determined. This activates the enzyme into performing its catalytic function.